Welcome to our Math Intervention virtual classroom where math knowledge makes things easier. Today we're going to be looking at Common Core Standard 6EE C9. What that means is that we're going to use variables to represent two quantities in a real-world problem that change in relationship to one another. We're going to write an equation to express one quantity thought of as the dependent variable in terms of the other quantity thought of as the independent variable. We're going to analyze the relationship between the dependent and the independent variables using graphs and tables, and we're going to relate those to the equation. Let's consider the relevant vocabulary today, which might be new to you. A dependent variable is a value that will change when another value changes. In this way, the dependent variable depends or relies on the other value. The other value that has the ability to influence the dependent variable is called the independent variable. Independent means not dependent. Although the dependent variable depends on the independent variable does not change because the dependent value changes. Let's consider an example. A school band sold tickets to their concert. The table below shows the relationship between the number of tickets sold and the amount of money they collected. Since the money collected depends on the number of tickets sold, we call the money collected the dependent variable. And the number of tickets sold, the independent variable. Now let's look at the problem from your worksheet. If you're just now looking at the assignment posted in our Google Classroom, this is the problem from the guided instruction section. So a ball is dropped from different heights. The table shows the height of the first bounce after the ball is dropped. Since the height of the bounce depends on how high the ball was dropped, we'll say that the height of the drop comes first. We'll call that our x value. And the height of the bounce, we'll call that y. So first we have the height from which the ball is dropped, and that influences the height of the bounce. If we were to try to calculate the value of the y variable, we could see here that the height of the bounce in each case seems to be half of the height from which the ball was dropped. So we could say that y is half of x. Now that we know the relationship between our x and y variables, we can graph them. Notice that our independent variable is on our x-axis, and the dependent variable is on our y-axis. This is a problem that came directly off of an old New Jersey SLA test. Notice that the values on the x and the y-axis don't exactly match the values from our table. But since we know that any value of y is going to be half of the x value, we could just look at our x values and we could determine what the value on the y-axis should be. For example, if our x value is 200, we know that the y value is going to be half of that, so it should be 100. And we could just plot a point right here where they meet. Let's see if we could actually draw a line representing all of the values of x and y on this particular graph. We'll just take another couple of points. If we choose any easy value here on the x coordinate, let's say the height is 300 inches. So the y value should be half of that, which would be 150. So we'll put a plot a point right there. And if our x value, if the height of the drop was 100 inches and y is half of that, y should be 50, and there's our point. Now we could just continue to plot a bunch of points to represent all of the values of x and y. Or now that we have just a few points, we could draw a line connecting these points, and all of the points along this line would represent our relationship between x and y. And we see in each case, y would be half of x. So there we've graphed the results of that particular equation. If you have any other questions on this assignment, please feel free to reach out to me. You could email questions through our Google Classroom. Please complete the worksheet assignment and complete the attendance form. And you're done for this week.